try this. The air's really active today, isn't it? Beautiful, though. Feel the cold, wet rain on your face. Nice, brisk breeze. See those clouds? Know where they are? Same place we are. They're in the atmosphere. The atmosphere. Isn't it great?
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Brought to you by the ozone layer. We block out ultraviolet light so you don't have to.
We live in an ocean of air. Our atmosphere is thick enough to let us live and breathe, but it's too thin to float or swim in. If you think of the atmosphere as an ocean of air, we live on the bottom.
Sorry, Bill.
Our atmosphere is thin, very thin. In fact, if this globe were the Earth, the atmosphere would only be this thick. I mean, this thin. Only 10 kilometers. Yet that's thick enough to let every living thing on Earth, including you and me, breathe. Now take a look at these. These are our atmospheric tubes of science. And right now, they're full of an invisible mixture of gases.
What would that be?
It's air.
Oh, yeah.
Now down here, we have 2 thermometers. So let's say that down here is like the surface of the Earth where the lab is, and up here is the icy blackness of space. You see, we have big chunks of ice here. Now, what would happen if the Earth had no atmosphere, if there were no air above us?
I don't know.
Well, let's try it. Using this pump, we'll take all the air, all the atmosphere out of this tube. There. We've pumped almost all of the air, almost all of the atmosphere out of this tube. Now take a look at this thermometer. You see that it's reading a few degrees cooler than this one? That's because there's no air, no atmosphere. That's because air, the atmosphere, acts like a blanket and keeps the world warm. In fact, most jackets and blankets work by having fibers that hold air next to your body, and that's what keeps you warm. The atmosphere has layers, like blankets, so it keeps the world warm, and it protects the world from comets and meteors. And the atmosphere is where all clouds and rain hang out. The atmosphere is wild.
At the time the moon was losing heat, it was also losing its volcanic gases. And it is from such gases that atmospheres form. But with a weak gravitational field, the moon was unable to retain even the heaviest gases. Earth's gravity held most of its gases, gases that eventually formed a primitive atmosphere.
Universal Pictures presents a tale so amazing, it's rising to the top of the box office. Catch it before it disappears into thin air. It's the incredible Voyage to the Top of the Atmosphere. Tremble as the turbulent troposphere whips up weather and churns massive amounts of innocent air. Stagger as the strapping stratosphere protects you from deadly ultraviolet light. Thrill as the titanic thermosphere thrashes gamma rays and absorbs heat from the sun at the same time. This summer, see the stars shine like you've never seen them before as you voyage to the top of the atmosphere.
We'll be operating this sailplane in the troposphere. It's the lowest layer of the atmosphere and the thickest layer. It's thick enough to support me and this whole plane. It's pretty wild.
We're getting higher and higher in the atmosphere. The lower atmospheric pressure is affecting our altitude indicator. And we can tell pretty much how high we are, not only by looking, but by looking at that indicator. The less atmosphere over our heads, the lower the atmospheric pressure. And that's how we can tell our altitude. The lower the pressure, the higher you are. That's how pilots figure out how high off the ground they are. They set their altimeter to the pressure at the ground. And as they go up, the pressure goes lower. The lower the pressure, the higher the altitude. You with me? There's a lot of air in the atmosphere. About 5.5 billion tons of it. On somebody my size, there's about a ton of air pushing down on me all the time. But the pressure in the atmosphere changes depending on where you are. It's hot. We're in Death Valley. Death Valley is the lowest point in North America. There's all this atmosphere over our heads. Take a look at this. It's my pop bottle barometer of science. What I've done is stretched a balloon over a small pop bottle. And I put it in a larger pop bottle with ice and water. That keeps it at about the same temperature. Then the air pressure pushes down on the balloon and makes this straw needle go up. And look, we're here in Death Valley, and there's so much atmosphere over our heads. There's so much air pressure that the needle is off the scale.
Something's off the
It's
scale.
off the scale. You know what I'm saying?
Yeah, I know.
Off the scale. That's a lot of pressure. It's air pressure pushing down on us. Look, it's off the scale. Off the flippin' scale the other way. That's because we've climbed up to 2,000 meters. That's, well, so it's over 6,000 feet anyway. That means there's less air over our heads, less atmosphere. And that means less pressure pushing down on the balloon. So it swells up and makes the needle point down the other way. Off the scale. All because of pressure.
Instruments tell us of jet streams of air. Fierce winds circling the globe far above the clouds we see. We live at the bottom of a turbulent ocean of air.
Let's go swimming.
You know how your ears hurt when you dive to the bottom of a pool? It's from the weight of water pushing in on your ears.
The same thing is true in the atmosphere. The weight of the air pushing down makes about 3 kilograms on every square centimeter.
You've got frog lips, Bill. Why is that?
If you ever get a chance to go up in an airplane, the pressure is much lower, so you may feel your ears pop. Because up here, the pressure is lower on this side of your ear than it is on the inside. And sometimes it equalizes, and that's when it pops. Oh. Troposphere!
Stratosphere!
Why, hello there, and welcome to my Rocky Mountain High Country kitchen. You see, there's less air above our heads in the mountains, so the water I'm heating in this pot can boil more easily. With less atmosphere, less air pressure pushing down on the water only needs a little bit of heat before off it flies in a bubbly, steamy bowl.
Take a look at this. It's our plastic cylinder of science. And in here is this thick plastic disc. Now, right now, there's air pushing down on the disc, and the air inside here is pushing up. And the forces are about equal, so the disc just stays here. But what would happen if we took all the air out from underneath of the disc? We can do that with this pump. Now then, we get just the weight of the atmosphere from here all the way to outer space, pushing down on the disc with nothing underneath it pushing up. We can measure the force of this with this scale. This takes a minute, so hang on.
Bill? Bill, I'm getting a little bored here, Bill. Want to play a quick game of cards,
The
guys?
atmosphere's pushing down.
Just deal them out here.
Look at that. About 150 kilograms of weight. That means the atmosphere is pushing down on this disc with 150 kilograms. Pushing down all day, all the time. And just think, on a guy my size, where I'm bigger, the atmosphere pushes down with almost a ton. All day, all the time. Isn't that wild? See, the atmosphere is thin, but it's heavy.